Hello, everybody. I'm Will Porcello, one of the lab assistants here at the Hanlon Financial Systems Lab at Stevens. Joining me today is Professor Brian Moriarty. Professor Moriarty, thank you for joining us.
Of course. Glad to be here.
Mr. Moriarty is currently our instructor for the FA 550 class, which is Data Visualization Applications. Besides this, he's also currently employed at 2 Sigma. So, Mr. Moriarty, tell us a little about yourself and specifically what steps did you take that led you to start teaching data visualization?
So about 12 years ago, I was working full-time here at Stevens as a professor in the Art and Technology program. And there was a certain desire to introduce more technical matters, technical applications into the Art and Technology program. And so I designed a course from the ground up that was originally geared towards art students, and we were using a programming language called Processing, which is based on Java, which we used for the entire course. But there was also kind of the other technical considerations that I built into the course as well. Due to the success of that course, I was asked by then the Financial Engineering program in 2013 to design a graduate level course in data visualization. So that is how it came to be, and now I've been teaching the course for 11 years.
So how has the course evolved since you first began to teach it? And can you share any insights or challenges that you faced over those 11 years?
It's evolved quite substantially because the discipline has evolved as well. So like I mentioned, the course started as essentially a Java-based course for a very kind of boutique programming language. And from there, I started using things like something called D3, which is a JavaScript-based programming language, and basically kind of just looked at how the industry was evolving and trying to adapt the course appropriately. And at first, that was purely just kind of like research on my part, but then I started looking at what I was doing in my work. So I was working at Wiley down the street here, the publishing company, followed by Pearson, and then finally 2 Sigma. And I was looking at not just the things that I did, but what other people, other practitioners were doing. How were we addressing data problems and the visualization thereof? So the course evolved a lot because, and there was a lot of experimentation because using web browser-based technologies like D3 or using end-user applications like Tableau Desktop, Tableau Server, looking at other elements as well, like the R programming language and something called ggplot2. But I also I combined what was happening in the industry with how students were responding to the material. So, for example, this past semester, I've rebuilt the course again for about the 4th or 5th time, about every 2 years, and it's really geared more towards Tableau technologies. And I expect that it will continue to evolve over the next several years as well.
So how does this class stand out kind of from other classes in just at Stevens in general, and specifically maybe in the financial analytics curriculum?
Well, Stevens in general, going back to how the course came to be in the first place, actually I designed 2 courses originally, and one has actually never run. It's always been this one that's been popular. But it was really looking at, like I said, introducing something more technical in the art program originally, but then here in financial engineering / analytics, it was actually kind of quite the opposite, which was introducing creativity into the engineering discipline, right? So, because there is a technical element, you have to learn a programming language or learn the specifics of a piece of software, but there's also a sort of narrative structural component. In fact, part of my course goes into things like screenplay writing, because with data visualization, you're not just taking data, porting it into an application, and done. You're developing a narrative. You're telling a story that is going to be impactful, that's meaningful. And I think that's a real challenge for students initially, because a lot of the other courses in financial analytics are really technically geared towards a specific solution. So statistics-based courses, modeling-based courses, data cleaning kind of applications, and building things like data lakes. They're very, very specific and tailored towards some technical problem solution pair. Whereas my perspective, and I think my role, is to say, well, that's all great and very important, but what else can you do? And how do you actually derive impact from all this technical knowledge you're gaining from these other courses? How it is different from other courses at Stevens writ large is, I think it blends the creative and the technical sort of engineering side together in a way that's fairly unique.
Okay. And you kind of talked about, I guess, not to put words in your mouth, but it sounds like one of the skills that you kind of gained from it is the ability to kind of interpret data and just kind of interpret that into an actual result. What are there other skills you think that are valuable for students to take away from this course? And I guess if so, what other skills are like particularly valuable?
I think probably the most important skill is, and maybe this is not a skill per se, but it's being able to think for oneself, right? So because one of the challenges with data visualization and data analysis in general is, frankly, you can tell any story you want, right? And that story can be meaningful and impactful, but it also can be completely manipulative and kind of, shall we say, ethically challenged.
Yeah.
So I think one thing I like students to take away from this course is the ability to go find data anywhere. I give a bunch of sources. I say, here's 50 places you can look for data on the internet, and say, well, your job is to go find the thing that is really most interesting to you, that you can tell your story. And I think that really is a breakthrough for a lot of students, because a lot of our students in this course, undergraduates and graduate students alike, have spent, possibly 15, 16 years of schooling, and they haven't really had to think that way. And they haven't really had to say, like, okay, I have an abstraction of telling a story about something based on data. What do I do? And sometimes, especially early in the semester, students will freeze on that because of, my friend over at insert school name here, we're just given data sets and told to go process them. Well, okay, that's great for that student at that school, but part of my ethic and part of my objective in this course is to say, wait, that's not the way the real world works. A lot of times it's, you're given sort of the general parameters of a problem, but you're not just like handed the data set and say, go visualize this. You really have to kind of from the ground up take the general idea and turn it into something, impactful.
Actually, as kind of an aside thing, I actually think that's, if anything, that's one thing I've gained from the course when I took it. Even though I was remote, it kind of helped me think more about, like, when I'm doing a visual, what story it's telling. So I just want to say as an aside, so you definitely met that expectation of the skill to teach. So we kind of talked loosely a little bit about ethical implications when you're kind of framing a story from data, and regardless what that data is or how you're choosing to visualize it. So kind of zoning in on ethical implications specifically, what are some important implications in maybe just the field of data visualization or data analytics as a whole, and compounding on kind of the skills that students take away, how do you think this course helps to impart that knowledge for students?
Really the most important part of the ethical considerations component of this course is that with data visualization, you can tell any story you want, right? You can be hyper selective on whatever your intent is, whatever your messaging is. You can, frankly, manipulate data to your own ends. And that is sometimes a dangerous power to have, right? You can sort of massage a story in any way you want. So And a good example I have, so a lot of the drive I get is I look at Twitter to find what data visualization practitioners are doing up to the minute and sometimes incorporate that into the course.
Just keeping up to date.
You'll see things like graphs of like performance of stocks or funds or whatever, and you'll see graphs that kind of zoom in on a particular detail and say, well, this stock or this cryptocurrency is going to perform in a certain way because of X. Or you're going to see things like candlestick charts of performance of something over time, but it's framed in such a way as to tell a particular narrative that can often be misleading. So that's what I mean when I say when I discuss ethical considerations, because if you can zoom any way you want or include or exclude data by any means you desire, ask only the questions that you want to ask as opposed to letting the data yield to you what the story is. So on that note, actually, one thing I always instruct students to do is to come into their subject matter, to arrive at their subject matter with a set of general questions that they seek to be addressed, to have answers to, but be open to the possibility that your story is going to be different than your expectation. You're not just trying to confirm a preordained result. What you're trying to do is understand what the data is trying to tell you, right? And embrace things like outliers, embrace unexpected patterns and behaviors is, I think, a more valuable takeaway than to have a preordained or predetermined message that you're trying to tell.
Mm-hmm. So, taking a lot of the tools we discussed earlier, Tableau, packages in R, and then obviously you can branch out into a lot of other things, which class, of course, does. How does learning these tools, Tableau, R, even like Python, how does it help prepare students for a career in financial services or really any industry as a whole, particularly maybe data analytics, data science?
Well, I think there's two parts to that. One is something I've discussed earlier, which is critical thinking.
Mm-hmm.
So you're given an abstract problem in your first job out of graduate school or out of undergraduate. And I've certainly seen this before, where it's like, senior manager says, go make some pretty charts for me.
Mm-hmm.
And sometimes this kind of actually kind of raises my ire a bit in the professional environment, because I'll see somebody come to me with something they developed from some data about something, and like, ooh, it's the ugliest graph I've ever seen. But it's like, oh, the manager likes it. And I'm like, oh, okay, fine. But so I kind of have to take off my data visualization hat and say, well, yeah, as long as they're happy. But it really boils down to being given an abstract problem and coming up with a solution, right? And that applies to anything, right? It doesn't matter whether it's data visualization, data analytics, or something completely different, working in publishing. But also, increasingly, and we've heard this probably for 20 years, possibly more, we live in an era of, that is awash with data, right? About everything. Most stuff we don't even know about.
Mm-hmm.
People talk about things being tailored, having tailored ads for them or different things. And I think there's so much data and there's so much to analyze, so much to understand. And what is the real backbone of data visualization? It's to make good, informed, quick decisions, right? I mean, the typical interface you'll have if you develop something for your data analyst,
Mm-hmm.
a beginning data analyst, is you'll be given probably just some sources of data, not actual data, and say, well, make something out of this. And what is it for? It's to drive a decision. It's to drive a decision about buying a product or an investment decision or anything. So for example, in my prior work at Pearson, one of the things we had to work on was developing I guess the 2016 version of AI applications. My team had worked on developing software to deliver different material to students based on their level of expertise, or more importantly, their level of non-expertise. So that you would have basically an educational program supplementing your in-class work that would emphasize your weaknesses to make you better at them, right? So I think that's kind of what we're getting at here is most students who enter the class really have very little background, often zero, in anything data visualization related. And I think I help provide them that kind of acumen, but at the same time help them with the critical thinking required that will apply to any position they do.
Building off the topic of the finance industry and preparing students for it, how do you ensure that the topics in the course aligns with the needs of professionals in the industry?
Well, I think I borrow from my experience, right? So it could be some abstraction of work I'm doing now, but usually it's something from further in my background, like working on things like pitch decks and stuff like that, where it's just, okay, there was a problem that I had to solve, and how did I address it? What did I learn from it? What did I have to learn to solve the problem? And I think, kind of imparting that experience on students. What I often emphasize in my course is that this course may be structured differently than you're used to because it tries to be, it aspires to be more representative of the real world, right? So in a typical college course, or high school, or anything probably from the second grade on, you are exposed to things like exams, quizzes, tests, those kinds of things. And I think for me, and I'm only speaking for myself, that's not really like the real world. It's, you cram for some exam so that you can retain the knowledge about some subject for a fleeting period of time. In, sort of in contrast to that, what I like to emphasize is, what are some things that each student can take away that they'll not forget? So I focus on having, basically a handful of assignments throughout the semester that are additive in nature. So, for example, in the redesign of this course right now, my first assignment had nothing to do, practically speaking, with data visualization. It was essentially a research methods assignment. It was just to provide students with a foundation to arrive at a topic, develop questions, find the support materials, be it research or be it data, and then kind of build on that foundation. And and then each layer that I put on top of that is, okay, so essentially it's, okay, now you know how to do some basic research, whether you've done it before or not, and then let's essentially play around with tools. And I even tell students, I don't expect the initial result to be very good, and that's okay. What matters is where we arrive at. We have 14 weeks to do this, so let's see where we are then. Let's just think about building layer on layer so you arrive at that point. So, and I think how that kind of is reflected in the real world, as we say, is it is rare, not always the case, but it is rarely the case that you are given something, an assignment at work, that looks like an exam, right? It's not like you're, go cram on this for 12 hours. It does happen. It absolutely does happen. In most cases, it's like, we're going to deliver this product in 3 months. Tell us our strategy. What are we doing? And you have time to kind of scope the problem and figure out the appropriate ways to solve different problems that arise during your process. I think that's what I try to reflect is sort of the typical work process.
So putting a cap on topics of working in the financial industry, what advice would you give to students who are kind of aspirant to a career in fintech, financial analytics, data analytics, or any role that you feel is really applicable from data visualization?
Okay, I'm going to be a little bit perhaps controversial here and say that don't get obsessed with, as someone with 20 odd years of experience, do not get obsessed with packing your resume full of every sort of emergent technology and having a surface knowledge of a bunch of different things. And I really would emphasize the importance of knowing a few things and knowing them well, knowing them very well. Right? So, what I see a lot, what I've seen a lot over my career is people who say they're conversant in a lot of different things, but it's really only on the surface level. What I would strongly urge is, if you find an interest, technically, from any course you take, be it mine or anyone else's here, really explore the topic and know it, because that will be valuable when you're interviewing, and be valuable when you start in a new position, that you set yourself up well because you have a very strong foundational knowledge on a subject. So I think that's probably the most important thing.
So that concludes all of our questions. Mr. Moriarty, thank you again for joining us. Hopefully for anybody who's considering a career in financial services or data analytics, I heavily encourage them to check out this class. Having taken it myself, I found it really insightful. And for that matter, hopefully the answers you were able to hear today, you found insightful as well. Everybody who's interested in, I can't think of a better way to put a spin on it. Like, how do I end that? It's been so long. Like, I don't really watch a lot of media, honestly. It makes me realize I watch like TV shows and that's it, but.
So you need a cliffhanger instead.
It's like, leaving it off a cliffhanger, it's like, it just doesn't seem right, but.